So let's continue with more of the 3D transform properties. In the previous video, we defined a perspective that set up our 3D space. But we're not limited to this viewport perspective only. We can actually change and set a different viewing position or origin with the perspective origin property. So in our body rule, we will add WebKit perspective origin. Like the perspective property, perspective origin has to be defined on a parent or root element in order to give the transformed children depth. So with this, we're sort of setting the vanishing point of our 3D space by moving the perspective origin up, down, left, or right. By default, the perspective origin is centered on the viewer, so we get a head-on view of the transformed element. Well, this is because the default perspective origin is equivalent to a value of 50%, 50%, which sets the X and Y position in the center. Perspective origin takes two values. The first value is for the X position, and the second is for the Y position. And it can accept length units, percentages, or the keywords left, center, right, top, and bottom. If we only defined one value, the second value will simply default to center. So let's go ahead and make the perspective origin 100%, 100%. So we'll save this. And in our browser, when we hover over the element, we can see how our perspective origin is now positioned bottom right. So we can kind of see the bottom right corner of the element coming at us. And if I limit the rotate 3D function to the x-axis only, we can see this a little better. So I'll go ahead and make the z-axis 0, so it only rotates on the x-axis. And now we can see the perspective origin a little better. In our perspective origin values, an x value under 50% moves the origin to the left. So let's make it 10%, so we can see it shift to the left. And an x value over 50% moves the origin to the right. In the y value, a value under 50% then moves the origin up. So let's make the x 50% and the y a value of 0%. So now we have a center top perspective origin. And like I said, we can also just use those position keywords in place of the percentage values. For example, center top. But we'll go ahead and leave the perspective origin at its default value of 50%, 50%. And since that's the initial value, we can simply omit it. Next, we'll take a look at the translate z function, which translates or moves an element along its z-axis. So in our wrap hover rule here, we will define the translate z function. Now, in its argument, a positive value will move it towards the viewer. So, for example, a value of 200 pixels will move it 200 pixels closer to the viewport, and a negative value will move it 200 pixels away from the viewport. There's also the translate 3D function, which moves the element on the x, y, and z axis. So this one accepts three arguments, one for the x, one for the y, and one for the z axis. So the first value is for the x axis, which we will make 100 pixels. We'll then make the y axis 50 pixels, and finally we will add a 150 pixel translation to the z axis. So we'll save this. And when we hover over it, we can see it moving 100 pixels to the right, 50 pixels down, and 150 pixels towards us on the z-axis. Pretty cool. We can also scale elements on their z-axis with the scale z function. Like the scale x and y functions, scale z only accepts a number argument. But this time, the number gets multiplied by the element's current position on the z-axis. So, for example, if our element is positioned 100 pixels on the z-axis with a translate z of 100 pixels, and we give the scale z function an argument of 2, this will scale the z-axis by 200 pixels because the value 2 is multiplied by the translate z value of 100 pixels. So this is pretty much the same as only having a translate z of 200 pixels, because that's how far up it's moving on the z-axis. And if we give our translate z function an argument of 200 pixels, it's the equivalent of a translate z of 400 pixels, and so forth. So as we can see, scale z is dependent on the translate z value. Since the perspective we defined on the body only applies to its direct child elements, the other nested elements, like the side A and side B divs, are not affected because the 3D perspective does not directly apply to them. So their transform style is flat. But we can change that by telling the browser to pass down its 3D space to these elements with the transform style property and the value preserve 3D. So in our transform.css file, in our wrap rule here, we will give it a new property, WebKit transform style. And we will give it the value preserve 3D. So we need to add preserve 3D to the wrap element because it will pass down the 3D space to side A and side B nested inside. So now these children of wrap are also being transformed in the same 3D space. Now, because of this, we can now flip our wrap element so that we're able to see that side B div as its backside. So we'll do that with a rotation on the y-axis. So in our wrap hover rule, we'll go ahead and add the rotate y function and give it a rotation of 180 degrees. So we'll save this. And we now see it flip over 180 degrees. But we're not seeing that side B div as its backside. There's one more thing we need to add. When elements are in 3D space, there are times when the backside may be visible. As we can see here, we're able to see the reversed or backside of the Mike the Frog image. But we can control whether or not the backside can be seen. By default, the backside on every element is visible. To tell the browser to hide it, we'll need to use the backface visibility property. So in our CSS, we will add the backface visibility property to both divs because we want their backsides hidden so that we're able to see their adjacent div as its backside instead. So in our wrap div rule here, we'll add WebKit backface visibility. So like I said, the default value for this is visible, so we want to set it to hidden. So let's take a look at this in the browser. when we refresh and hover over it, we still don't see it. Well, that's because we need to reverse the side B div so that its backside faces in. Remember, we set it to hidden, so that's why nothing displays when it turns over. So back in our CSS, we will create a new rule to select that side B div, and we will apply a WebKit transform property with a rotate Y function. And we will go ahead and give it an argument of negative 180 degrees. So we'll save this. And in our browser, we can now see that nice side B div when the wrap element is flipped. Now we'll change the value to negative 1 turn so we can see it rotate 1 full circle. And there you go. The benefits of using these 3D transform functions like translate 3D, translate Z, and rotate 3D is that it triggers hardware acceleration in the browser. Transforms and transitions are not automatically GPU accelerated. So by swapping to GPU mode, we're able to leverage GPU power on the desktop and mobile devices. This way, our sites and applications can perform faster than is possible in those browsers running on the CPU. Support is also looking pretty good for these. Unfortunately, Opera does not support 3D transforms just yet. IE 10 does have partial support, only because it does not support the transform style preserve 3D property, so we're not able to 3D transform those nested elements. In our next deep dive, we'll take transforms a step further by combining them with keyframe rules in order to create our own CSS animations. See you soon.